This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. In this video, we're going to solve this nonlinear polynomial inequality that you see right here. Make sure you've already watched my introduction to these kinds of problems. And as a reminder, here are the steps that we could use to solve nonlinear polynomial inequalities. We write the inequality with a 0 on one side. We factor, set each factor equal to 0 to find the critical points. Mark those on the number line. If we have an equal sign under the greater or less than symbol, we'll put dots because those will be solutions. Otherwise, we'll put circles on those critical points. And then we'll test the other intervals to find other solutions. All right, so here's this problem. Now, so the first step is to make sure that we have 0 on one side, which we already do. And the second step is to factor, which this is already in factored form. So next, to find the critical points, we set each factor equal to 0. So let's see, we've got x equals -3 or x equals 4. Those are our critical points. And are those solutions? Well, we have greater than or equal to 0, so that means when x is actually equal to each of these numbers, those are part of the solution. So just keep in mind, those are going to be solutions. So on the number line, we want to mark where -3 is and where 4 is. And we know that those are solutions because of the equal sign under here. In other words, when you plug in -3 into this original inequality, you'll get 0 squared, which is 0 times something, is certainly greater than or equal to 0 because it's equal to 0. So -3 will be a solution, and 4 will also be a solution. So now that leaves us with 3 intervals. Before -3, numbers between -3 and 4, and numbers larger than 4. So we want to do some test intervals. So we could pick any number we want that's smaller than -3. So how about we test x equals -10. Okay, it doesn't matter what you put. And we're going to plug those in, that value of x, into this inequality. Now I think it's easier to plug it in when it's factored. In this case, it is already factored anyway. So imagine if you put -10 in the parentheses, in for x in the parentheses. So in the first parentheses, if you wanted to write it out, it's -10 plus 3 squared times -10 minus 4. So some people prefer to actually put those numbers in, but it really doesn't matter what number that is. You just have to determine whether what's in the parentheses is going to be positive or negative. So this is obviously a negative sign, right? -10 plus 3. But you know what? If you square it, let's see, so this is a -7 squared, this is a -14. But if you square -7, it's actually a positive number, right? It's 49 times -14. So if you were actually going to plug in the numbers, you can tell this is going to be a negative number. Now, I don't usually do all that arithmetic. I usually just say, well, what would happen when I put in -10 for x in that first parentheses? Okay, well, if I put in -10 for, I'm going to get a negative number, which I'm going to square, and I'm going to get that times another negative number, because -10 minus 14. Well, when you square a negative number, it's positive, so this is a positive times a negative, and therefore it's negative. That's all you really have to determine, whether it will be positive or negative when you plug in -10 for x, or any number smaller than -3. All right, let's test a number in between -3 and 4. Anytime I can, I plug in 0. 0 happens to be between -3 and 4. So if I put in 0 for x, I end up getting 3 squared, or what really matters is that I have a positive number that I'm squaring, times, if I put in 0 for x in the next parentheses, that gives me a -4, which is just negative. So a positive number squared is positive times negative. So I would get a negative number. in this interval as well. What about over here? I want to pick a number bigger than 4. So let's test like 10. That's a number bigger than 4. So if we put 10 in for x in the first parentheses, that'll be a positive number squared. And then I'm putting in 10 in the second parentheses, that's also a positive number, right? So I got a positive number, right? Because a positive number squared is still positive, times positive, and I have a positive number here. Okay, now we have to pay attention to this right here. We want to make sure that we get a positive number in those intervals, right? Because I want, when I multiply whatever I'm putting in for x here, when I multiply this left-hand side, I want it to be greater than or equal to 0. And we've already taken care of where it's equal to 0 at -3 and 4. So now I'm looking to find in the intervals where it's positive, and there's only one place here. So it's going to be over here is the only place where it's positive. So this looks really different than the other problems we've done, right? So check this out. I have this solution, this single dot over here at -3. That's a solution, plus I also have everything from 4 to infinity. So my solution set right here, which I'm going to write using interval notation, is the number -3, right, union, oops, sorry, don't want to have a parentheses, I want to have a bracket because it includes 4, the interval from 4 to infinity. Now, this is one way to write that -3 is a solution. If you wanted to do interval notation, it would be kind of weird, but you could say the interval from -3 to -3, right? Kind of funny looking though, right? All the numbers from -3 to -3 is the same as the number -3 itself. All right, so here's our solution. Now I want you to look at this problem again. So keep in mind, here's our solution from -3 and 4 to infinity. Check it out. Right here, it says x plus 3 quantity squared. It really doesn't matter what I'm going to put in for x. Did you notice that whatever you put in for x, whatever number ends up being in the parentheses, I end up squaring it, which will always be positive, except when x is exactly equal to -3, right? So did you notice in all of these intervals, see I have a negative quantity, a negative number squared will give me a positive. Here I have a positive number squared, I get a positive. And here I get a positive number squared, I'm going to get a positive. So you know what? This first factor, x plus 3 quantity squared, which is really like 2 factors, will always give me a positive number. So the interval that's the thing I really need to check is this x minus 4. So let's see if you would have reasoned that out ahead of time, how you could have done this problem just a little bit faster. So here we are again. We've got x plus 3 quantity squared times x minus 4 greater than or equal to 0. And so we're looking for what intervals make us positive. So we still start out the same. We find our critical points, -3 and 4. And since it's greater than or equal to 0, we know that -3 and 4 has a dot on it to show that's a solution. Our test points are the same as well. We could just pick any number to the left of -3, any number in between -3 and 4, and any number, this was 10 over here, any number bigger than 4, so let's say x equals 10. But this part right here is always positive, so really what matters, right? We know that's going to be positive in any case no matter what, after we square it, okay? After we plug a number in for x and we square it, we're going to get a positive number no matter what. So really what matters is this other factor, x minus 4. So when x is -10, that's a negative number, makes this negative. When x is 0, that makes it negative, so we'd have a negative here. And when you put in 10 into x minus 4, that's positive. And again, there's only one place where we get a positive number. So from there, we get exactly the same solution. All right, so if you have something squared, right, some quantity squared, right, as long as it's not 0, it will always be positive. That would be true if it was any even exponent, squared to the 4th, to the 6th, to the 8th period, 8th power, etc. All right, if it's cubed, well, not as easy. Okay, so our solution set is going to be exactly the same. We've got negative 3, oops, forgot the 3, union from 4 to infinity. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.